Thanks, Kala. Welcome. Hello, everyone. Today, Dan and I are going to be, let's see if we can get this presentation going here. All right.
All right, cool.
So, aloha and welcome. Today, we're going to be talking to you guys about changing perceptions, motivation, students, efficiency, effectiveness.
Whoa, Sean.
What?
Do you have any idea how many words you just
we
put in
got
the
a lot to
audience's
get through.
head? Yeah.
Oh.
Let's clear things up a little bit. What are the main ideas we're going to be talking about today?
Okay, all right, fair enough. How about perceptions, students, math, themselves?
Oh, okay.
Yeah, something like that.
That clears things a little bit better. But can you organize the ideas so it's perfectly clear to the audience what we're talking about?
Take care of that. All right. Sorry, I get a little excited. Talk about changing perceptions of math by teaching students to teach themselves.
All right, there we go. Much better.
All right.
So, as our title screen just showed you, how we organize words affects how we understand the very meaning those words are meant to convey. So, if we don't take the time to organize words, we can be very overwhelmed and confused by something like this, instead of having, that's overwhelming and confusing. Instead of having something clear and understandable like this. So the next thing we want to talk to you about is how prior organization of words can affect how we understand and perceive new words and the ideas those words are supposed to represent. So.
Okay, all right. So, you know what? 1 second. Sorry. Did I tell you that Marissa and I are getting a dog?
I don't think this is the proper time to talk about that.
But we got the time.
I guess we... Actually, to be honest, it's kind of embarrassing to admit I don't really know what a dog is. Can you explain?
Dan, you're a high school teacher and you don't know what a dog is?
Hopefully none of our students are watching.
All right. Well, I mean, you guys stay with me on this. A dog is, 4 legs, has a head, furry, and can lie down. I mean, we'd all agree, right? That's what a dog is. Dan?
Don't you guys already have one of those then?
Oh my, Dan, you are blowing this presentation, bud. Come on, man, let's get it together. What do you think? Can you draw a picture for these people, what you think it is?
Ugly table with a 70s shag cloth in the middle of your guys' living room. That's a dog, right?
Dan, how can you confuse 4 legs? You know what? This is a dog, Dan. It's got 4 legs. It barks. It goes woof.
Oh, I've seen one of those before.
All right, Dan, you got to fix it for these people. You got it. How did you confuse a dog into a table?
Okay, well, you said 4 legs. Furniture has 4 legs. Lies down, folding table, okay? Furry, 70s shag carpet. You can put that on the table. Clearly, that's a dog, Sean.
Yeah.
That's a dog.
Dan, I'm not even mad. I'm actually impressed. How you did that is beyond me. 4 legs. How about an animal, Dan? Did you stop and think about that?
That's fair.
Furry, lays down. That is a dog, Dan. Okay, got it? Okay, all right. So what this is meant to illustrate is dog versus table. This idea is schemas, the very ways we organize words in our brain, especially the organization of prior words, affects how we perceive new words. In the case of math, where it's even more abstract, this gets challenging. In this case, I could show a picture to Dan and be like, oh, this is a dog. Got it? All right. But how about in math, where we're like, okay, hey, come here, quadratic formula. Come on, kids, let's pet the quadratic formula. Or, did you see that pesky quadratic formula running across the street yesterday? I didn't think so. All right? As ideas get more abstract, we ourselves need more set and firm schemas. Dan's going to talk a little bit about how that looks in math.
So, based on dog versus table, what is the key component to correctly perceiving and learning mathematics? Developing proficiency with number use seems pretty important. Memorization of processes seems pretty important. Cognitive organization of math words seems pretty important. But Sean, I realize you didn't know I put D in there. I'm sure the entire audience wants to talk about spaceships. So
stop. He's going to try to show you through a schema how he can connect perceiving and learning all the way to spaceships. I'm not even going to let him do it.
All right,
Dan,
fine.
Please, let's get to the point.
Okay, so the real answer is actually C. Okay? Based on this, Sean and I wondered, what are the math words that students actually have to organize as they're going through their education? Well, what we did was we went through the Common Core standards. Now, if you're not familiar with them, these are a set of standards that are sweeping across the entire United States. Almost every state has begun adopting them in some way. These are the words that a kindergartner is expected to know, at least to have in their vocabulary, based on the concepts in those standards. Okay? Then we move on to first grade. Now we realize you're not going to be able to read all of these. We just want you to get the big picture. Okay? Then we move on to second grade. We're just going to jump up to sixth grade for you. Notice the similarity between this and our title screen. It's pretty overwhelming. As you can see why some students get to sixth grade math and go, I'm done, can't do this anymore. So what we wondered was, is it possible to organize these? Well, not only is it possible, we've actually done it. So instead of having a confusing mess of words, you can cognitively organize them based on definition. Right? So then when a student moves on to first grade, instead of having a bunch of words strewn around, they start connecting them to everything else. Now we're going to jump up to sixth grade again for the sake of time. Okay, now we realize you can't see everything on there. However, things are now organized so they can perceive and understand all this information in a proper manner. The observation that Sean and I had from this was, well, what if they don't know one of these words? What if they don't have one of these connections? What if one of these connections is connected in a not so efficient way? So what we thought was, well, not only would it affect their success, but if they're overwhelmed by all this information, it's going to affect their confidence in mathematics, and it's going to affect their motivation to even try mathematics. So, Sean, you want to give a little context?
Yeah, let's try to give you guys some context. So stop, think for a moment. What is an activity or a job or an interest that you personally do right now that you feel very confident in? I would imagine if I asked you to list a whole series of words that are related to that, you could give me a long list. You could even describe to me how they were connected. Imagine when you first started that. What if Dan or myself gave you a map? What if we showed you how those words were connected? How would that have affected your perceptions? How would that have affected your motivation? How much quicker could you have gotten to the level you're at now? With that, we're going to show you how this looks in our class. All critical terms plus organization leads to effective perceptions, which helps drives motivation and success.
So as Sean just said, we're going to talk about how we create an experience in our classrooms where students can now cognitively organize information, effectively perceive information, and have an overall clear understanding of mathematics. Now, just like this basic outline here, what we do is we get our students to move from something that's scary and messy, this is a lot of kindergarten information, into something that's organized and understandable like this. So, as we said before, we start off with vocabulary. Okay? We're sure there's a few terms up here in just a moment, okay, that you've probably seen before. We're not going to test you, don't worry. You're after TEDx Honolulu stuff is not going to be dependent on passing a test. But from getting them to go through and build their vocabulary and literacy with these, we then have them start mapping them out based on definition. In kindergarten, the starting point is normally numbers. And then from there, we have our students go through word by word and look at the definition, and you can actually see connections in those definitions. Whole numbers, counting, place values, all have numbers in the definitions.
So what we can start to do, as you saw with operations expressions, I'll just go back real quick, kind of show you what that looks like. We can even start to hit them with more terms, and they start to know where to place them. What we've categorized this as is a tipping point. You can see that as you get more and more, it starts to become more and more clear without even showing them math, how these ideas relate. The best part is they can do this on their very own. Dan now is going to show you what it looks like when we show them math content.
Yeah. So notice we haven't done any math problems yet. Our students now have a big picture understanding of how everything's related. They're not quite as overwhelmed when we start presenting them with activities, labs, examples that they go through on their own. So we do a thing in our class where essentially when they go through this content, they make a tweet. Now, if you're not familiar with Twitter, and hopefully all of you are now, essentially it's just a quick little visual and phrase that attaches to that word. So for example, with numbers, they might say something like, how many, give a few examples. Okay? And then if they ran to whole numbers, an observation they might make is 0, count up by 1, and give a quick little example. This continues on, but we realize sometimes two things can come up at once. Now that they have a structure in place, they can now handle working with multiple ideas at the same time and know how this content fits together to create an overall big picture understanding. So we move from something that's kind of scary like this into something that's organized and makes sense like this. Now, some of the effects it's had on our students is they now have this perception in their mind of, okay, well, if I see this word, I know what content's connected to it from my tweet, if I see this word, I know what other words it's connected to and the content that's connected to those, instead of this disorganized mess that's in their head sometimes when they're doing things high pressure like taking a test, ACT, PSAT, things like that. So Sean's going to share some more results.
So what does this afford us in our classroom? Well, as far as performance goes, we've completely and entirely started getting our students to teach themselves, okay? Stop and think about that. Actually teaching themselves. That can go on to any other class. So we've created a lasting student achievement, regardless of whether they connect with the next year's or following year's teacher, or when they go off to college, whether it's lecture-based, hands-on, they can actually have the confidence to teach themselves. The most amazing part is we've managed to do this without lecturing. That's right. Not one day of standing up like this towards you guys right now, lecturing. In fact, if we had it our ways, we would have just given you the list of words of how to do this, and we would have had you start building the map already. All right? But for you non-teachers, our students come in every day. They sit down, they start working in collaborative groups or on their own, and they start working with the words. They make their own connections, and they start problem solving creatively entirely on their own. So Dan's going to share a little with you how it's affected his algebra class.
So this is currently my second year of teaching. I'm an emergency hire, which means I have no formal teacher training whatsoever. Last year in my freshman algebra class, my passing rate was only 52%. Now, after implementing this, I have moved from a 52% passing rate all the way up to an 86% passing rate.
I've been teaching geometry now for 5 years. I originally came over to Teach for America, if those of you are familiar with that. I came over in 2006, the first quarter to actually come to Hawaii. I was placed at Waipahu. I did my 2 years. I stayed longer because I enjoyed the students here in Hawaii so much. They're great kids out here. For those of you that haven't had an opportunity to be in a classroom, they're amazing. I've never been able to break 60% pass rate in my geometry class, which has driven me nuts. Last year, I actually almost quit. I had applied, took my LSAT. I was looking at law school, and then Dan and I started thinking around with these ideas, and I've been able to move them from 58% to 89%. So, yeah.
So the next class we're going to talk to you about is statistics and probability. It's a new course at the school that we started, so there's no previous statistics on it. However, the book that we're using is a college textbook. The students are currently teaching themselves college material, and I have all of my students passing my class right now.
Dramatic build up there. All right, the next group I'm most proud of, as the reason I joined Teach for America, for those of you that are not familiar with them, you leave your undergraduate and you go to schools where students face many challenges. Many of my students face things from teen pregnancy to domestic violence, homelessness, healthcare issues. The list is long and very long. Because of this, we've had to come up with new ways of teaching. There's a lot of teachers doing great things, but one thing we're proud of is because we don't lecture, we can actually work with each student one-on-one. So instead of asking, hey, how's that math problem going? We move beyond that, and we can now ask students, hey, how's everything in your life going? Everything all right at home? And now that student, instead of walking in our class going, oh, God, math, they're like, oh, hey, I know Mr. B and Mr. Nash care. All right? Just that simple question has allowed me to move from 12% to 65%. And these are students that have failed math 2, 3. I have actually caught a handful of fourth time in algebra. And now they at least come to class and they feel like they can learn.
So what does this actually afford us? Well, by organizing ideas, we've been able to change and shift our perceptions of what learning actually is. So from this, we've actually been able to create a classroom experience that allows our students to organize ideas and change their perceptions of learning. And now we have a class where our students are learning how to do things like critically think, creatively problem solve, all on their own, instead of listening to me talk. And thank you for all listening, man. I'm kind of bored. So what's on top of that, we as teachers have also been able to reestablish our value in the classroom. Instead of just our content area expertise, we can now create an experience for our students where it's completely them doing everything and where they're just there to help them through it. And on top of that, what's kind of even more impressive to us is now we have students who are seeing the value in learning and education. The next two quotes we're going to show to you are quotes directly from our students about their experiences in our classroom. The first one says, "Now since I have this class, I think SMART is just organized. If everyone had a mental map and organized every idea, then everyone will be as smart as the other." This is from a student who's currently taking Algebra 1 for a third time. So, the next quote, "The day we were born, we pick things up, learn, and we adapt. We understand things based on the ideas we have learned. Our understanding of new ideas changes based on the way we organize past experiences and ideas. If one of our experiences or ideas is a bad one, then it will affect how we perceive new ideas or experiences. We can use maps to change the way we organize things in our mind to see all the possibilities in our lives." This is from a second-time student in Algebra 1, based on the experiences they've had in our classroom.
So, what has this afforded us? Well, we believe we've been able to actually start developing critical thinkers by teaching our students to organize ideas and recognize how they organize these ideas affects their perceptions. And this goes way beyond the classroom. Imagine thinkers that understand and recognize the very ideas and the power in how they organize them will affect the possibilities they see in their very lives. Think of the impact this would have on individuals. Individuals would recognize that all they needed to reach the possibilities in their lives would be the critical terms, the time to organize them, and just the time to see it all materialize. Imagine the impact that would have on communities. Communities could come together where individuals meet. They would recognize that, hey, we don't disagree. These are just perceptual differences. We could take the time to collect the words from everyone's maps and come up with powerful solutions that not just address one perception, but many perceptions. What impact would this have on society? Think about that. A whole society where everyone's coming together. It is because of this that we think developing critical thinkers is not only necessary for our children, but ourselves as well. The most important part is we believe developing critical thinkers is the lifeline for individuals, communities, to society to become what they want, can, dream, and should be. Thank you very much.